Good evening, afternoon, Jan.
Good morning, Michael.
Oh my goodness, I was just dealing with time issues on Postgres and Entity Framework and mapping. Should I use timestamp with time zone or timestamp without time zone? Datetime
Mhm.
offset versus date time. Yeah.
I think time will always be an issue,
Mm-hmm.
even at the end of times.
Yes. Yep.
Yeah,
It's the heat death of the universe, and somewhere out there, a black hole is asking, "What time is it again?"
yeah. Um, I set up everything last time, but on Discord we are not able to share both, I
Yes.
think.
Yes, that is true. Yeah.
Now, perhaps a solution would be to share with Zoom
Mm.
and then to present it on Discord
Okay.
to
Yeah.
the others. I don't know.
Yeah.
Um, that we have a Zoom session between us,
Mm-hmm.
and that from
Yeah.
there you
And and yeah,
you
there's also the option of just switching to Zoom. I know that we keep the Discord open so that others can join. Um, Most weeks we don't have other people joining, so maybe we
mm,
um, publish a schedule that says, okay, we're going to have open hours, you know, every every 4 meetings, and then it'll be on Zoom uh, in between. I don't know, something like that.
mm. Yeah, but we can keep Discord active at the same time.
Mm-hmm. Yeah, I'm trying to
You
think how to set up the recording. What's going to be on what screen and what rectangles I'm going to capture. Um, yeah.
will have the recording like you did last time with the Zoom, and Discord is just
Yeah, that's true.
a channel to broadcast.
Yeah.
Um, and if people would come in, they can interact through Discord, or we can point them to Zoom at that moment.
Yeah. Yeah. Okay. That's a good plan. Okay. Yeah. So let me get that set up for next week,
Okay.
and then yeah. So this week we can continue the modeling that we started, even though we won't be able to see um, the screenshot while we're modeling because of the split screen thing. But yeah, then to catch everybody up who's watching this on YouTube, we recorded on Saturday a 3.5 hour uh, hackathon where we did some modeling, and I have not yet sent that off to be edited. I wanted to understand what the story beats are going to be and give them good direction. So that will be coming at some point in the future. So you'll see that after you see us continue
Mhm.
on that modeling thing.
Michael, what I can do is share the screens one by one. Now you take a print screen,
Okay.
so then you can wait. I will put that, and then you can handle the different screens.
Yeah,
Um,
that makes
wait,
sense.
let me see that. So first of all, and we make it for better text readability, perhaps. Um, which screen is that? Um, yeah, well, I can just take the whole screen like that. So this was the setup
Mm-hmm.
that we were having last time. Let's put this, Michael, it was this one.
Yeah, that's
Do you see the,
yeah. It's very small because we've got the whole
yeah?
thing shared.
Um, what I can do is share it window by window if you want.
Yeah, or or maybe you can go ahead and take a screenshot of the dialogue and then paste it into
Okay,
the
right.
chat.
Chat gonna make. This is gonna make a full. Oh no, this is just the chat. How do I get to the
Yeah.
chat? Um,
Oh, that's in
is
a
that
virtual machine, so you can't just copy the.
no,
Yeah.
no, no.
Okay.
I'm not in a virtual machine now.
Oh, okay.
The chat
Yeah,
in
in
Discord.
Discord, yes.
Where do I find that? Is it the general text channel
Um,
general? Is that one?
yeah, you can paste it in general. That'd be good.
So this is okay. So that's one, and then I will take the mobile app as well.
Okay. And you.
Oh, if I on TeamViewer, no, he's taking a screenshot on my phone.
Oh.
Wait, I just captured the whole screen. And then I get it out. Yeah. Now I'm capturing really the whole screen.
Yeah. And actually, while you're doing that, there's another option that I just thought of. I have the, uh, you know what? I've got it. Yeah, I got it right here. So I've got the video that we recorded, so I can scrub to the point where we are looking at that dialogue.
I'm getting there. Should be this one. Up.
And I just saw it.
Yeah. I think you should have. Yeah.
Okay, there we go. That's
Okay,
good.
now get back to to the book up.
All right. So
Yeah. So
then
then I stop
copy that.
sharing.
Boom.
Okay.
And then boom. And back to. There we go. Okay. Yeah, we figured out this technology thing. All right, now I can put the snipping tool over here, and then we can see. Let me go to this one. Okay, so now people can see what it is that we are talking about. Okay, so we've got a dialogue. This is the primary dialogue where where a dispatcher.
You don't share it for the moment, so people don't see it.
I have it up on the stream.
Okay.
So yeah. But yeah, so this is the primary dialogue that people will, or that dispatchers will use in order to schedule tasks for a worker to work on. So you've got the client, and there's a drop down there, which is probably going to be the primary focus of what we'll be working on today. And then we've got the work location, the yard, that gets filled in when you select the client, because that's a flattened list of yards for clients. And then we've got the
task.
The task itself, yeah. And then at the bottom we've got tools.
Yeah.
Okay. So in order to accomplish that, and this I did, I will go ahead and share so that we can talk about this. Back here. Share this screen here. Okay.
Yeah.
All right. So this is the model that we designed inside of a Polyglot notebook. So the user creates a supplier and then invites another user to join as a worker. Supplier has clients, clients have yards, and then when the dispatcher creates a task, they create a task for a particular yard. But the information about the yard is also copied into the task. So we've got the task yard name and yard address, so that we have that history of where the task, or what the state of that yard was at the time that the task was assigned. Similarly, we copy in the client name, and then we've got the delete and restore, and we've got two ways to assign tools. You can create one on the fly and give it a name, and then that exists only in that task. Or you can create a task tool association with the lookup table of all of the tools that have been configured within the supplier. So then you assign the task to a worker, and that uses the mutable property pattern because the intent is that a task will be assigned to just one worker, and if you reassign it, you replace that worker with the next. So that is the model for the task interface. So what we would like to work on, I believe, today is to work on some specifications for how to populate that UI and to see how things are going to change as somebody's working with it. So, good summary?
Mm-hmm. That's a very good summary.
All right. Yeah, that's the problem with not releasing things in order. Okay, so in order to accomplish that, there is some guidance in the Jinaga.net documentation about modeling. And so last time we set up our notebooks, so brought in the libraries, configured a client, and set up this structure. So far, we've got the packages and the client, and then one of the models. So the specifications that we want to build will go into the scenarios folder. So, so for example, scenario A brings in the Jinaga client, so it can start to create facts against it, and then also references one of the models. So the lines got kind of jumbled up here, but it's either model A or model B. Probably model A since it's scenario A. But so let's come back here and let's create this 2-scenarios folder right here inside of our notebooks. And then we can Control-Shift-P, create new blank notebook. Oops, I think I hit enter too fast. IPY and B, C#. And then this is going to be our scenarios. So it's going to import both the package, or the, let's see, I called it setup. Yeah, in the guidance, it's called client. I called it setup. Let's go ahead and rename that. There's nobody nobody looking right now. Okay, so client, and so then our scenario is going to goodness, I've forgotten the syntax already. Pound bang import. Yeah, in fact, go ahead and do that. So we're going to go to models and we're going to get dispatcher. And then go to setup and get client. And so if we save that into the scenarios folder, we'll call that assign or create task. It's about more than the assignment. All right, now we can run that with .NET Interactive, and it should. I don't see where it says it's running. Try again. Oh. 1-models. Of course it does. So go out from here into models. Oh, dispatcher. There we go. So now it is bringing in everything from the dispatcher model. So that includes all the documentation, all the graphs that were rendered. And then it also executes the client IPYNB, which should create a client for us. So now we can use that Jinaga client, and we've got all the methods. So the very first thing that we want to do is go ahead and set up a scenario. So let's refer back to this diagram and create all the facts that are necessary in order to, first of all, to see what would be inside of this drop-down. We're going to want to see a set of clients and some yards.
Yeah. Because if we open that drop-down, that combo box.
Yeah, unfortunately I can't. It's a screenshot.
If you open it, you get a multi-column combo box. In my case, it's a fake one, but it looks like a multi-column combo box, which has the customer names, which has and the addresses completely. So actually, it's a combination of the client here and the yard location.
Okay. So
because the thing was, a particular customer can have multiple yards. So if he has multiple yards, you will see 2 lines.
Okay. So let's go ahead and set up some data that does that. So we know that we are going to need a client. So we'll have a fact that is new client. But a client needs a supplier. And it needs a good. Now, first of all, let's call that client A, because we're going to end up making another one. But then we need to get that supplier. So our supplier is equal to Jinaga client, fact, new supplier, and a supplier has a creator and a good. So we need the creator. So var creator, and we can use I need to await these because they are async. Now I could use Jinaga client.login, and that would be the current logged in user, which is a fake user. That is let's make it a little bit more correct. So it's not actually the logged in user that has created the supplier, but in fact is a single use principal. So we'll have the fact that is a new user, and the public key is going to be some public key that represents the single-use principle. Dash, dash, dash. So, let's go ahead and use the Jinaga client to render these facts. So I want, let's just get down to client A, everything that's necessary to build that. And so there we've got our single-use principle, the creator of the supplier, and the client belongs to the supplier. So far, so good. And now we're going to need multiple yards. So looking up here, the yard belongs to the client. So let's go ahead and create yard A1. So this will be a new yard for client A, and it has the yard GUID, but nothing else, because the name wouldn't go there. The name would go, in fact, I'll just, yard A1 name. So that would be the yard name value, and then prior an empty array. And then we can do yard 2, and it'll be the same kind of thing. So now let's look at everything necessary to get to yard A1 and yard A2. There we go. Starting to get some stuff. Now, in addition to a name, actually we want to see the names in here.
Yep.
Yeah. There we go. So now we're seeing the names of the yards for the client. So now, in addition to the names, we need the addresses. So let's let Copilot generate some addresses. And let's see how close it got to the right data type. So we've got the yard, we've got street, number. So number needs to go here. Then we've got postal code. So postal code is next. And then we've got the place and the country. Put this in France. And now we've got yard A1 address.
Well, it's quite amazing that Copilot, it puts all the information there, but in the wrong order.
Yeah. Yeah, so you would think that it has the data type in its context, but I think it might be because it was executed in a previous notebook and then the results were imported. Copilot doesn't actually have this code. You would have to look over here on this tab, and the actual yard address is somewhere up here. Yeah. Oh, that's the... Oh, yeah, we had the content management discussion. That was a good discussion. Yeah. Or the CRM discussion. But, yeah, here, somewhere up here is the yard address. Yeah, there it is. So it might just be that this other tab wasn't in context, or it wasn't scrolled to the right place and it was looking in the wrong part of this file. But yeah, that would be even better if Copilot and the type system work together so that Copilot um, could interrogate the type system, get a little bit more information about what's in context, and then generate code from there.
Because the fact that he comes up with a name like any town or a postal code 12345 means that he knows what he's talking about.
Yeah, yeah. Yeah, postal codes tend to have that form. Yeah.
Hmm?
And so now that it has that, it should be able to just... Come on, you can do it. Boom, there. It put it in the same place. Be a little bit more creative. Okay, now it knows it's supposed to be a slightly different address.
Okay.
Okay. So then we've got the yard A2 address and still no semicolon. It really wants to put the semicolon on the end, but it doesn't realize that the semicolon causes it not to render. So there we've got a model of a client having 2 yards. To finish this out a little bit more, let's go ahead and create a client with 1 yard. So we'll have client B. So that's a new client. You know what? We're not including the client name anywhere. Client A name. Yeah, so it's figured that out. So let's do client B name as well. And then we're going to have yard B1, and it's back in the same place as client A. They share they share a facility, I guess. 2 clients working on the same yard. All right. So now in order to get everything showing up here, I should client A name should be able to put that in there, and then
Perhaps make it a different street name, then we see that it doesn't mix up things.
Yeah.
Another street.
Yeah.
It's not adapting the numbers.
Yeah. Oh, and it put the semicolon on the end. No more semicolon. Yeah. So let's do 79. Okay. So we are getting an interesting model now.
Yeah.
So 2 clients, one with 2 yards, another with 1 yard. So what we want to do then is to write a specification that's going to give us the contents of the dropdown, which has the client name, and then the various columns of the yard name, and then the various columns of the yard address.
Yeah.
And it is such that if a client has multiple yards, you get multiple rows. So really, a row represents a yard. A row doesn't represent a client. So I will write yards in supplier. So the supplier is going to be our starting point. So we want all the clients, all of their yards. So yards in supplier, that's going to be given a supplier, which is, yeah, nice guess. I want to match supplier facts. And then we're going to say from, let's go through the client first. So client in facts of type client. Let's see. Oh, yeah, this is not a method. There's no parentheses at the end. So given a client in facts of type client, where client dot supplier is equal to supplier. Then we want to do from yard and facts of type yard, where the yard client is equal to client. So now here, if we select yard, then, well, that's just defining the specification. Let's do await Jinaga query, and it got the order wrong again, but yards is supplier, comma supplier. So now let's just render, not render query results, it's render facts. Render those yards. So that just picks out those particular facts. So that's a good start. If I just say yards, then instead of the graphical rendering, we are going to get the drill down, so we can see each yard has a GUID, has a client, so there's that GUID, has a supplier with that GUID, has a user with that public key. None of that stuff is interesting for us to show on the user interface. So we want to project the interesting things about the yard. So I'm going to say new and create an anonymous object. So the first thing that we want is the client name. So that's going to be facts of type client name, where let's see, let's first do it in this consistent way here, where I want from client name and facts of type client name, where the client name is equal to the client. So I've picked out those client names, and there are no next client names. They haven't been replaced. So not facts any client name next, where next client is equal to client. Nope, that's not how that works. Where next dot prior contains client name. Okay, so that's going to exclude the names that have been replaced, that have been superseded. And then from this, I want to select the client name dot value. So that actually we'll call client names. We'll make that plural because there's no way to constrain this to be just one. But if there have been no concurrent edits, then you will get just one in your client names. But if there have been concurrent edits, you'll get more than one, and they'll be your candidates, and you do something about that. So now let's run that, and we get these values that now have the client names. So we can see client A, client B. And they're showing up inside of arrays, but they only have one element. So that's the pattern there. Now let's continue that pattern a little bit and do the yards. So now I've got the yard names. So we're going to select the yard names belonging to that yard where there's not a replacement yard name. Get those, and now we can see that we've got client A, yard A1, client A, yard A2, and client B, B1. So we're getting the right behavior. And we can continue that same thing for the addresses. And this time, let's get it right. We've got place. Let's see, so street number, postal code, place. Street number, postal code, place, and country. Yep, those are the ones. And now we have those structures. And so from this, you can see how to project that into a view model. In fact, let's go ahead and finish that last step just so that we can show how things do that view model thing. So I'll say yard view models. So I'm going to not select many, I'm just going to select and then here I will select just one name, so that's going to be first or defaults, and then project that into something else that we want to show on the screen. And same thing with the yard name. And yard address. In fact, since you want multiple columns, what we can do, this actually works a little bit better with the other syntax. So let's have GitHub Copilot translate syntax for us. So there, now it's translated that to the from address, from the from syntax. But now at this point, what we can do is we can define some variables here. So we'll call this yard, our client name. Whoops. It went all over the place. Okay, right here. We'll say let client name equal yard client name's first or default. We'll do the same thing with the yard name and with the address. That way, we've got, yeah, so that's a collection of strings. Yeah, an queryable with strings. That's an queryable with strings because we've already projected those values there. And this is an queryable of these objects here. It didn't know how to singularize. Interesting. Or maybe I just deleted the S and it said, oh, that's what you want to do. Okay. All right. So now we've got the yard name. And then if that's null, then we use this. And then here we can break it down into the street. And then have the null handling there. Okay, so that should flatten it all out. Oh, and now we should be able to see our yard view models. And there we go.
Yeah.
So all that processing would happen while translating from the results into view models. Because the specification language doesn't support things like first or default or null coercion or anything like that.
Okay, all the information is there. That's very nice.
Yeah. So at this point, I think it would be helpful to simplify things a little bit here. When we take a look back at this specification, there's a lot of information in that specification, and it can be pulled out and put into the model. That way we can read things a little bit better. So let's start at the inside here. So what we're trying to do here are we're trying to get the yard name or the yard names for a particular yard. There's a lot of stuff going on there. If we went back to the model and looked at yard name, we can create a body for this record, and we can define we want to define a relation of type yard name, and that's going to be yard. We'll just call it names. And then using the arrow syntax, we're going to this is a lambda property, or an expression bodied property. So we can do a relation dot define. And we don't have to specify the type; it all gets inferred. And so now, if we had a facts repository, we could do all of that stuff. So from yard name in facts of type yard name, where the yard name equals yard, and there is not a facts.any nay. One of these I'm actually just going to put nay into the library. It'll mean not any. Yeah, there's not any yard name. Yeah, I got that completely wrong. Called next, where next dot prior contains the yard name. And then from here, we'll select the whole yard name, not the value. The reason being that we might want to come back later and use the names relation in order to do an actual mutable property pattern. We want to be able to edit. So doing this, save that. We can come back here and let's run everything so that it re-imports from the dispatcher. And now we should be able to say something as simple as yard.names. Select name.value. Let's see if it needs to be restarted in order to bring that in. Why can you not see that? Okay. DWS yard name, it's got this relation called names. Okay, well, let's do the full reload and see if that makes it work. Okay, yeah, there's our data. Yard.names. I don't understand why that's not working. Well, we shouldn't have to run this in order to get it to pick that up. Because it's an import. It should be running it in the other context. But let's just make sure. Yep, we've got that there. Everything is saved. We're gonna run it all. Well, this is supposed to make our lives easier. But okay.
In the future.
In the future, we'll demonstrate that working. Right now, let's just get back to this, and we have what we want. So yeah, all of that stuff about relations is documented in encapsulating specifications. You can define conditions where you say there's a condition property, condition.define, or you can define relations, where you take a whole specification like we did here and put it into relation. Oh, that might be it. I didn't do this. Did I? Let's just make sure. Yeah, I did. Okay. That is a relation of yard name. This one I did actually go to the string, but if you were to continue this example and you get to an edit window, then that's going to cause issues. All right, so we've got the first bit of what we want to show in our user interface, and that's our drop-down list of clients. And yards. Okay. So then when you select something, it's going to fill in the client name. That's a user action, so it's just going to take the selected row, set the client name property in this dialogues view model, and then also set the street number, postal code, place, and country. So it'll set those all up. And we also wanted to grab the yard that was actually selected. So in addition to all of this, we want to capture the yard fact itself. So that way here, in addition to all of these data properties that we want to show to the user, we can keep track of the yard fact. So now when we go down to save, we should be able to, we'll hold down to that yard fact, so we should be able to save a new task, have the predecessor yard that we've selected here, and then create a whole bunch of successors that represent, copying the client name, copying the yard address, and the yard name all into there. Oh, I just noticed the work location does not include the yard name here.
No. But that's a good thing to add. So the fact that you added it is interesting.
Okay. All right. And then this is all input except for this list of workers. So, so input just like you would normally do input, but now in order to populate this this list of options, we want to have the worker drop down. For the client, or not the client, for the supplier. So here we can do something very similar. So we've got workers
In supplier.
In supplier. So let's see how much you can guess. Given a supplier, match. Yep. Then it went completely off the rails. So it was a good start. So from worker in facts of type worker, then we select new worker. Now we're going to have the names is equal to facts of type worker name, or from worker name in FACSO type worker name. Yep, and now it's getting the pattern. Oh, okay, we didn't actually model worker name here. Okay. Yeah, when we got down to tasks, we added task worker. Here's worker. I think we put worker up here with all the other users so we can provision a worker. But we didn't have any way of capturing the worker's name. So here the pattern that I will usually use is straight off of jinaga.user. I'll have a successor that is the username. That way when you log in, it can grab the name from whatever your identity provider is and capture that as a fact. And that way you end up with a username, and you can refer to that username no matter what kind of user it is. So I think that makes a lot of sense. So let's just go ahead and add that real quick. So here we're going to have a fact type, DWS user.name, and it's going to be public record username for a user, and a string value, and username array prior. So just a simple little type definition. So let's see if it's able to bring in that type definition when we get here. Yeah, so we know that we've got a problem there. So what we really want is from the username in facts of type username, where the username user is equal to the worker user. So that's good. And the name has not been replaced. Okay, it's able to bring in the new type. So yeah, that's not the reason that the relation isn't working. So that gives you all the names of the user that the worker represents. And the drop-down list is just showing the names. It's not showing anything else.
Oh, there's names.
Yeah, so I think that's all we need there. But of course, we need to capture the worker themselves as well. So now I can run that query. I can project it into a view model, and we can take a look at the results. Now, so far in our test data, we didn't put any workers in there. So dot value. So that means that this is going to be an empty collection. But we have some confidence that this is a correct specification. If we want to test the specification, we'll go and put in a worker. In fact, we probably will want to put a worker into our example data in order to be able to create the task and assign the task to a worker. So the upshot is that in order to display this user interface here, we will want to, as it loads, execute these two specifications. We'll actually want to do a query, not a watch, but a query. That way the drop-down lists are fixed at the time that the dialog appears. If we used watch instead, then that means that things might be added or removed to these drop-down lists, which is not behavior that users are expecting.
So if somebody else modifies or add a user, for that user to appear in the drop-down list, you will have to quit the screen and get back in.
Yep. Yep. And that matches people's expectations. Now, of course, if you want to change people's expectations and do things differently, then you can use watch and then have the watch callback populate those lists.
What would be unexpected about populating the list automatically?
It's just now that I think through it, given what we talked about on Saturday, you've got a user interface where you can have multiple tabs that you break apart and you put into different areas, even on different screens. So it could be for for some reason that you say, okay, I need to create a new task, and then you come down here to the users and you say, oh, that user's not there. Let me go to a different window and complete the provisioning process. Yeah. And then when you just look at this tab again, you pop this open again, it's going to be there.
Yeah.
So yeah, maybe that's not so bad.
Mm-hmm.
Yeah,
so that's the power of Jinaga. So why not use it?
Yeah. There are already some training opportunities for our users, like the fact that that a value can have or a property can have two values, and there might be a concurrent edit. We have to train our users that's the case. They're used to their data just being overwritten if a problem happens, and then they shake their fist and they enter their data again if they notice. But yeah, so we are trying to give them a better experience than they've had before. So maybe this falls under that. Now there's one case with the mutable property pattern. Since here we are creating a brand new task. This one doesn't show the that case, but if it's an edit, then we want to bring up the prior versions on load and not update the interface if new information comes in about mutable properties. So, for example, if we were editing the task name, and this task name here is a mutable property of a task, then if somebody else edited the task name and it immediately updated on our window, that could be a problem because maybe we've typed in the value that we want. Maybe we were just about to push save and change happens. And so we really do want to treat it as a concurrent edit if I open the form, you open the form, and then we make the change. It doesn't matter if we actually hit the save button at exactly the same time, as long as we both opened the form and we both saw the previous version. We'll want to capture that as prior, what it was at the time that we opened the form, not at the time we push save.
Yeah, because otherwise it becomes very confusing.
Yeah.
You see a wrong name, you start editing it. Somebody else sees the wrong name, he starts editing it. He saves, and at once you say, it's correct anyway. Then you start thinking that something goes wrong in your brain.
Yep. So yeah, those are the choices you make as you build the application, and Jinaga gives you the tools to make either choice.
I think it's better like you say, and then somewhere have a window with all the conflicts. Okay, I have a customer with two names. Which one do you want?
Yeah.
And if it's the same name, all the easier.
Yeah. The interface that I've been going for is um, add a little button that only shows up if there's a conflict, and then you can open that button, or you click that button, and it opens up a little window that shows you all of the candidates.
Okay.
That's what I've done in Blog Maui to try,
Mm.
kind of try that interface out, and I think it tells you what's happening. I've chosen a little merge icon, which to me says what it means, but I need to user test that to see if other people feel the same. But
Yeah, because
yeah,
there are these situations where you can say, for example, the dispatcher is allowed to do the merge,
mm,
but the workers, they shouldn't have to worry about that.
yeah, yeah. Okay, yeah. So that's going to be an interesting conversation when we get into designing, um, designing a user interface. So this user interface
Mm.
shows up on the dispatcher application. If we build so the worker is going to have a different application. It's going to be on a mobile device.
Mm.
If we just don't put that merge capability into it, then we get that behavior. If you want that to be a security thing, that one, um, that the worker is not allowed to. That's going to be, yeah, that's going to be an interesting conversation. So we'll get there. But yeah, for right now,
Mm.
that is setting up some specifications in order to build a user interface, and really test our model. Make sure that we haven't forgotten anything. Like, for example, the username.
Yeah.
Now it's there.
Mm.
All right. So that's all we have time for today. So I will pop that into the where's the right screen? There's the right screen. Okay. Yeah. So I will push that to the repository, and
Mm.
you can start playing around with that. Yeah. If you want to to continue modeling different aspects of the application, or just trying some experiments, then yeah, we can get back together and go over what you did. Otherwise, we'll just get back together
Mm.
and keep on going.
I will try to play a little bit with it because it starts getting interesting.
Yep. Yep. And I really like Copilot being right there inside of it. So once it gets trained up and it knows what we're asking for, then
Mm.
it can just generate whole things. Say, oh yeah, I can do yard addresses. I see exactly, exactly
Mm.
what you mean.
All right. Because then the next time, perhaps we can make that little user interface
Mm-hmm.
based on these specifications
Yeah.
and see how that runs.
Yep. Yep. Do a little bit of WPF coding.
Mm. Mm-hmm. It gets real form.
Yeah.
So next time we try the Zoom thing with Discord as a
Yes.
broadcast.
Yes.
Yeah, you have fiber at your place, or
I do, in fact, yes.
okay?
This would be very difficult without that.
No, because if you're still on ADSL, it might become a little bit limited.
Oh yeah.
Okay, Michael, then we see each other next week.
Indeed. See you then, yeah.
Okay, okay.
Thanks.
See you. Bye bye.
Bye.